All right, so here we have a 3 by 3 system of equations, and we want to solve this using Gaussian elimination. All right, so the first thing we want to do is write the augmented form of the matrix here. So let's put these coefficients where they need to go, right? So the first column represents all the x coefficients, the second column would represent all the y coefficients, and the third column here, right? Remember, there's a vertical line for the equal sign, and then we're going to put the -5 here on the right side, right? So these are the coefficients of the first equation. And then we're going to go ahead and write the 3, 2, -6, 6 here. And -2, 5, -3, 8. Okay, so this is the first step, right? We're going to get the augmented matrix. Now you notice that here we have a 1 in the first row, first column, right? That's always good, right? So then the next thing we want to have happen is we want to get zeros down here. Right? But we have to use row operations. We have to use this first row and use the row operations to get a 0 in this entry and a 0 in this entry. Okay, so we note that, well, since this is a 3, right, if we multiply row 1 by -3, so we'll multiply row 1 by -3 and add that to row 2. By doing so, obviously these numbers will change, but we'll get a 0 here, which is good, right? Similarly, because of the 1 here, right, we can multiply this row by 2. Right? So we'll multiply row 1 by 2, add that to row 3, and that'll be the new row 3. Okay? Notice that when you multiply row 1 by -3, okay, and then add it to row 2, row 1 doesn't change, right? It's still going to be the 1, -3, 2, -5. Okay? So what happens as a result of this? Okay? So once again, this row 1 does not change, but we are doing row operations on it to get zeros in the other two entries here, right? So -3 plus 3 gives us 0, right? -3 times -3 is 9, plus 2, which gives us 11. -3 times 2 is -6, plus -6 here, which gives us -12. And -3 times -5 is 15, plus 6 gives us 21. Similarly, we're going to use row operations on the third row here, right? So 1 times 2 is 2, which add that to get a 0. -3 times 2 is -6, plus 5 to get -1. 2 times 2 is 4, plus -3 to get a +1 here. 2 times -5 is -10, plus 8, that'll give us a -2. Okay, so this is what we get now, right? Now what's the next thing we want to have happen? We want to get a 1 in this entry here, right? In the second row, second column, right? So there's a couple things we can do here. We can divide this whole row by 11, right? We can divide this whole row by 11, and that'll give us a 1 here. Now we do get fractions here in these two entries, which is okay. We can deal with that. But notice in the third row, right? It's already a 1. Well, it's a -1, okay? But we can do a row operation on that, right? We can multiply row 3 by -1, and then switch it with row 2. So what's going to happen once we do that? Okay, so we know row 1 doesn't change, okay? But I'm going to multiply row 3 by -1 and then switch it with row 2. Notice what happens here. We get a 0, 1, -1, and a 2, and 0, 11, -12, and 21. Okay? So that's good, right? We have a 1 in the first row, first column with zeros below it. And then this is called the main diagonal here, right? Remember, the whole point here is we want to get 1s along the main diagonal. Okay, so this is good, right? We have a 1 now in the second row, second column. Okay, so next, we want to get a 0 below it. Okay, so we have to use which row operation here? We have to multiply row 2 by -11, right? So -11, row 2, plus row 3. Okay, and then that should give us a 0 down here. Okay, notice nothing else changes. So we're going to write these rows as they normally are, but I'm going to multiply row 2 by -11 and add it to row 3. So 1 times -11 gives us 0 here. -1 times -11 is +11, minus 12 is -1, and then -11 times 2 is -22. Okay, plus 21 gives us a -1. Okay. So notice that here we can just multiply row 3 by -1. Okay, so if you multiply row 3 by -1, that should get these guys to be a positive, right? Okay. So let's do that. -3 row 1. I'm sorry, -3 row 3, right? Okay. So I want to multiply row 3 by -1, so we get 1. Everything else stays the same here. But here we get 0, 0, 1, 1. Okay. So here when we have 1s along the main diagonal and 0s everywhere below it, this is called the row echelon form. Okay. We call that REF for short. Okay. Now in the reduced row echelon form, we also want to get 0s in these 3 entries here. Okay. So now we can use the 1s to do so. Okay. So remember, there is a particular order here, right? You notice the order that we've gone through, right? We got the 0 here, 0 here, 0 here, right? Now we want to get a 0 here, then get a 0 here, and then get a 0 in that last, well, not the last spot here, right? But this one, okay? And so it's very important that you get 1s along the main diagonals first and 0s below it, okay? Now notice we can use row 3, right? We can use row 3 to get a 0 here, and then use row 3 to get a 0 here, okay? And then we'll use row 2 to get a 0 here, and then we should be done. Okay. So what should we do next in this case, right? So we want to get a 0 here. Using row 3, we can do that, right? All we have to do in this case is just add row 3 to row 2. Okay. So once we add row 3 to row 2, what is going to be the result here? So look, this is the key, right? This is why we need zeros, right? Because 0 plus 0 is 0. 0 plus 1 is still a 1 here, right? But notice what happens when we add 1 plus -1. That gives us a 0. 1 plus 2 gives us a 3. All right, so we got the 0 here that we wanted. Okay, so let me just go move this over to the next page here. Okay, so we have the row 1, we have row 2 here, we have row 3 here. So what's the last couple things we want to do? We want to get a 0 here and a 0 here, right? So we can do that using row 3, right? So we'll do, notice this is a 1, this is a positive 2. So if we multiply row 3 by -2 and add that to row 1, right? So we're going to take row 3, multiply it by -2, and add it to row 1. Okay? And that should give us the new row 1 here, right? But look at these zeros, right? 0 plus 1 is 0, 0. Okay? So that's why it's so important to get zeros everywhere else. Okay, -2 times 1 is -2. Added here, we get a 0. -2 times 1 is -2. Added to -5 to get -7. Okay. Everything else stays the same. We're doing this step by step here. I mean, if you want to sort of combine everything, you can. Okay. So what is we really have one last step here, right? Look, we got 1s along the main diagonal. We got 0s here, everywhere else below it. We got a 0 for these 2 entries, so there's one last step here, right? What is the last step? We want to get a 0 here. Okay? Notice we have to use row 2 for that, right? Because of the 1. Okay? So make sure you really understand the whole point of getting 1s along the main diagonals and getting this pattern of getting the 0s everywhere else. Okay? So what is the last thing we need to do? We need to multiply row 2, right? We're going to multiply row 2 by 3. So we're going to multiply row 2 by 3 and add that to row 1. Okay. So by doing so, notice what happens here. Okay. We get a 1, but when we multiply this by 3 and add it here, we get a 0. Right? Notice, multiply this by 3 and add it here, it's still a 0, right? So 3 times 3 is 9, minus 7 gives us a 2 here. Right? Everything else stays the same. And here we go, right? So remember, this matrix here is called the reduced row echelon form, or REF for short. Okay. So what does this matrix here tell us? What does the reduced row echelon form of the matrix tell us here? Remember, the first column are the coefficients of the x variable, right? The second column were the coefficients of the y variable. The third column were the coefficients of the z variable. But notice what this says, right? It's 1x. Right? It says x plus 0y plus 0z equals 2. Well, just x is equal to 2. Notice what the second row tells us. Right? 0x plus 1y plus 0z, well, that's just the y, right? Well, y is equal to 3. And what about the third row here then? Okay, z is equal to 1. So our solution then would be 2, 3, 1. Remember, this is a 3 by 3 system of equations, so we need well, this is not technically an ordered pair, right? But the solution is x is 2, y is 3, and z is equal to 1. Of course, you can always plug these back into the original problem, right? Make sure that everything checks out. In this case, it does.